A RAG system is only as good as the evidence that it retrieves. Before the LLM answers, the system has already made one of its most important decisions. How should the documents be split? That decision is called chunking, and it quietly shapes everything downstream. So when RAG fails, the problem often starts before the model even writes anything. In this video, we'll break down the main chunking strategies, why they matter, how to think about chunk size, overlap, semantic boundaries, and parent-child retrieval in a more practical way. Welcome to Scovia, where we make AI concepts feel like everyday ideas. Let's start with the basic problem. Let's use an example where a company has thousands of internal documents, like policies, contracts, support tickets, etc. Now, let's say a user asks, what is our refund policy for enterprise customers who cancel after renewal? The LLM does not read the entire document collection. That would be too expensive and slow, right? So the RAG uses retrieval. First, the system searches for relevant pieces of text. It gives those pieces to the LLM, and then the LLM writes the answer. But the retrieval system does not usually search full documents. It searches chunks. A chunk is just a smaller piece of the document. It could be 200 tokens or 500 tokens. It could be a paragraph or a section. Chunking is the process of deciding what those searchable pieces should be. And once the decision is made, the retrieval system is constrained by it. It cannot retrieve meaning that was split apart badly. It cannot rank a chunk correctly if the important clue is in the previous chunk. This is why chunking is not just about fitting text into a context window. Chunking defines the evidence units of the system. Let's say you have a document with a section that looks like this. Now imagine we split this text poorly. One chunk says enterprise customers may cancel within 30 days of renewal. Another one says to receive a prorated refund, this policy does not apply to monthly subscriptions. There could be another chunk that says refunds must be approved by the account manager. Each chunk contains a part of the answer, but no single chunk contains the complete policy. Now, if a user asks, can an enterprise customer get a refund after renewal? The retrieval system may retrieve chunk 1 because it matches enterprise customer and renewal, but the chunk 1 does not include prorated refund. Or it may retrieve chunk 2 because it contains refund, but chunk 2 does not clearly identify the customer type. The model now receives incomplete evidence. So it may hedge or hallucinate or answer with too much confidence. And when we debug the system, we might blame the LLM. But the real failure actually happened earlier. The answer was cut into pieces and no longer made sense independently. The simplest chunking strategy is the fixed size chunking, where this can happen. For example, split every document into chunks of 500 tokens. And it does work surprisingly well for many systems. But fixed size chunking immediately creates a trade-off. Small chunks are precise, but large chunks preserve context. A large chunk may contain all the necessary context, but it may also contain many unrelated details or be too long. The embedding becomes a blur of multiple topics. So the retrieval system might rank it lower than a shorter, cleaner chunk that only mentions refund. Small chunks can lose meaning and large chunks can dilute meaning. So that's a trade-off. And a common fix is chunk overlap. So instead of splitting it like this, we split it with overlap, which looks like this. The overlapping region helps prevent important information from being cut at the boundary. This is useful when documents are written as flowing prose, where one sentence depends on the previous sentence. But overlap also creates more chunks. More chunks means more embeddings, more storage, more retrieval candidates, and more duplicated context. And sometimes more confusion, right? If there are several overlapping chunks which all contain similar text, the retriever may return near duplicates instead of diverse evidence. So, overlap reduces the boundary failures, but it does not really solve the chunking problem by itself. It is a patch for one specific problem: information being split across edges. It does not guarantee that each chunk represents a meaningful idea. A more careful approach is semantic chunking. Instead of splitting text every fixed number of tokens, we split based on meaning. For example, a document might contain a section about refunds, then a section about cancellations, and then a section about billing disputes, etc. Semantic chunking tries to keep each idea together. This often means splitting by headings, paragraphs, topic shifts, or embedding similarity. The goal is that a chunk should be large enough to contain a complete thought. It does need to stay small enough to stay focused. This is closer to how humans read. We do not usually think in like 500 token windows. We think in units of meaning: a policy clause or a procedure step or a product requirement and stuff like that. When chunks follow the structure of meaning, retrieval becomes easier. The embedding represents one coherent concept, and the retrieved text is easier for the LLM to use. And the final answer is less likely to combine unrelated fragments. But semantic chunking also has trade offs. It is more complex. It may depend on document formatting, or it may behave inconsistently across messy sources. And sometimes one meaningful section is still too long. So, semantic chunking is a different design philosophy. Some documents are not just plain text, right? They have structure like tables, lists, or code blocks, or FAQs, etc. If we ignore that structure, retrieval can break in subtle ways. If you take a table as an example, one row might say plan, which is like enterprise, a cancellation window, which is 30 days, a refund policy, approval, etc. If we extract this as plain text and split it badly, the row can lose its meaning. The retriever might find prorated but not the plan, or find enterprise but not the approval requirement. For structured documents, chunking should preserve relationships. A table row should often stay together. A heading should often be included with the text beneath it. An FAQ question should stay attached to its answer. This is structure aware chunking. The principle is that chunks should preserve the relationships that make the content interpretable, because the LLM needs facts with their labels. In RAG, context is the relationship between pieces of text. There's another common failure. A small chunk is useful for retrieval, but the larger section is useful for answering. For example, suppose we have a long policy section called Enterprise Renewal and Refund Rules. Inside that section, one paragraph might say customers must submit requests within 30 days. That paragraph may be the most relevant match for the user query. But alone, it's ambiguous, like requests for what, which customers, which policy, etc. One strategy is parent child chunking. The child chunk is small and precise. It is used for search. But once it is retrieved, the system also brings in its parent section. So retrieval happens at one level, answering happens at another. This is a powerful pattern. It separates two needs that are often in conflict. For search, we want precision, and for generation, we want context. Parent child chunking gives the retriever a sharp target, but gives the LLM the broader evidence. This is especially useful for long documents with well defined sections. Most chunking is done before the user asks anything. The documents are split, the chunks are embedded, and then the retrieval uses that index for every query. But not every query needs the same kind of evidence. Some questions need a definition, like what's the refund window? A small chunk may be enough in those cases. Some questions need comparison. How does the enterprise refund policy differ from the standard plan? Now, the answer may require multiple chunks from different sections. And then there are some questions that need a procedure, like what steps should an account manager follow to approve a refund? Order matters here. Some questions need synthesis across documents. Has our refund policy changed since last year? Now we need version history. This means chunking should be designed around the kinds of questions the system must answer. A chatbot for policy lookup needs different chunks than a legal review assistant. A code assistant might need different chunks compared to a customer support bot. A medical search system might need different chunks compared to a product recommendation system. The best chunking strategy is not universal. It depends on the task. More specifically, it depends on the unit of evidence required for correct answers. Let's talk about evaluation. In RAG, answer quality depends on retrieval quality, and retrieval quality depends on chunking. So, when a RAG system fails, we should ask three separate questions. First, did the source documents contain the answer? Second, did the retrieval system retrieve the right evidence? And third, did the LLM use that evidence correctly? These are different failure modes. If the right evidence was never retrieved, the LLM is not the main problem. If the evidence was retrieved but incomplete, chunking may be the problem. If the evidence was retrieved correctly but the model ignored it, then prompting or model behavior may be the problem. Separating these cases prevents bad debugging. Otherwise, we end up improving the part of the system that did not fail. So, how should we choose a chunking strategy? There is no perfect value, but there are useful heuristics. First, preserve natural boundaries when possible. Do not split randomly through paragraphs, table rows, code blocks, or policy clauses. Second, include context labels. A chunk from a policy document should often include the section title. A table row should include the column names. A support answer should include the original question. And third, you should keep the chunks focused. A chunk should usually represent one main idea, not several loosely related ideas. Fourth, use overlap carefully. Overlap is useful near boundaries, but too much overlap can create duplicate retrieval results. And fifth, evaluate retrieval directly. Look at the actual chunks returned for a question, not just similarity scores or final answers. Read the retrieved evidence. Ask if a careful human could answer the question from these chunks. If the answer is no, the LLM probably cannot reliably do it either. And finally, match chunking to the task. For definitions, smaller chunks may work. For procedures, preserve the ordered steps. For comparisons, retrieve across sections. For complex policies, use hierarchy. For structured data, preserve labels and relationships. Chunking is not a default setting, it is a modeling decision. The practical rule is simple: chunk by meaning first and size second. Use small chunks when you need precise search. Use larger or parent chunks when you need complete context. And always evaluate retrieval before rewriting the prompt. I hope you found this useful. Please subscribe to Scovia, and as always, stay curious.